this is my module number 2 mini video, and today I'm going to be talking about cats and 3 of their traits and how that connects to this module. So the first one is coloring of the cats, which the 2 options are agouti and solid, or solid is also known as non-agouti. And agouti is just any sort of striping or tabby color of the cat. And then hair length, we have short-haired and long-haired. And then for ear shape, there's folded and straight. So going over to the parental generation, we have a mother who is agouti, short-haired, and straight-eared. So we have 2 copies of those chromosomes. And then father is solid, long-haired, and folded ears. And then to create the F1 generation, I took 1 chromosome from the mother and 1 from the father, and I got this combination. So the F1 generation, or this specific one, is heterozygous for all 3 traits. So I moved that over here so we could look at the map distances. So between the A and the L allele, there is 14 centimorgans, and then the L and the E are 10 centimorgans. And then next time on this board, we're going to talk about gamete type probability. So now, as if we know the coefficient of coincidence is 0.8, we are going to go over the gamete probability of these gamete combinations. So we either have a single crossover in position 1 or position 2, or a double crossover or no crossover. So as you can see, I have the calculations up there, and a double crossover is about 1%. A single crossover at position 1 is about 13%. A single crossover at position 2 is about 9%, and no crossover is about 77%. So the way I did the probability of a double crossover is I multiplied position 1 distance times position 2 distance times the coefficient of coincidence, and I got that it was 0.0112. And then the probability of a single crossover at position 1 is the distance at position 1 minus the probability of a double crossover, since you don't want to include those in a single crossover calculation. And then I got 0.1288. Thank you.